Hello, CC of Middleburg Tutors. This is your tutorial for our science for week 16. This week we are going to be back in Van Cleve and we're going to be working on experiment numbers 130, stretch, and 132, spurt. So both of these are really self-explanatory, so I don't think you need too much guidance on this. But we're just going to run through it just to make sure. So for stretch, we are working on the purpose is to demonstrate the effect of a tension force. And we are going to do that with the example of a balloon and markings on the balloon, stretching it out and then letting it go back again in order to see how that affects it. So again, when you read through your results and the why behind it, it really gives you some good dialogue that you can have with the kids. You can refer to your Miss Wizzle sheets that I've already sent y'all and any other research that you find that helps to describe anything else about tension force. All right, so we have a white balloon. Everybody's going to have a white balloon in their class and a Sharpie marker. You guys should have a marker already in your tutor bins. But if you need me to bring you one, then just let me know. So our instructions tell us to draw a square on a deflated balloon. So we haven't done anything to blow this one up yet. This is going to be not very easy to do because balloons do not lay down flat. So we're going to do the best that we can to draw a square on the balloon with the Sharpie marker. Looks pretty bad. Okay, divide the square into 3 sections. Use the marking pen to color the 2 outer sections on the square, so then the inner section is going to stay white. So I will try to color in one side and then the other. This is not easy to do on a little wobbly balloon. Okay, that's not so great. Let me kind of open it up here. All right, so here is my somewhat of a square. Both sides are colored in and the inside is white. So now we are supposed to inflate the balloon and observe the markings, and then deflate the balloon and observe the markings again. So we're going to see what kind of effect we have when we put tension on the balloon and then release the tension. So let's see if I can get this one blown up at all. Okay, so we can see a little bit how my balloon has stretched out and the markings have stretched out as well. And everybody can observe this and see what they find on theirs. I think if you mark on it, you know, in different directions, like I kind of did mine vertically, if you do them at a diagonal, then your markings will probably look different. If you do it horizontally, they will probably look different. If you do it kind of scribbly and smudgy, like mine is, then you will have markings that turned out like this. So then we're going to let it go and see what it looks like now. Pretty much the same thing as where we started. So this has shown us in this experiment that even though we gave it tension, when that tension was released, it went back to the way it was. You can do this multiple times, blow the balloon up bigger, make it smaller again, do it even bigger, bring it back down again, and so you'll be able to see what happens over time with tension force. And you know, when it comes back down, is it always going to come back down to its original size, or are we going to find something different? So again, there's lots of ways that you can talk this up, but this is really just your little object lesson on this one. All right, that's everything for stretch. Now we're going to go to 132, which is spurt. Spurt's purpose is to demonstrate what causes magma, which is liquid rock, to move. All right, so what we're going to do to demonstrate this is we're going to take a tube of toothpaste that has already had half of the toothpaste squirted out. So what's left is a tube that is halfway full. So on this tube, I don't know how well you'll be able to see this on the video, but the top half is pretty much empty, and the bottom, where it's bulging more, is very full. This is the size that you guys are going to have to work with in class. And the idea is for us to take it where we can feel the toothpaste in there and to squeeze our fingers and thumbs together and be able to feel how the toothpaste inside is displaced. So if I squeeze it here, then the toothpaste moves up and the toothpaste moves down, but it moves away from where I'm putting pressure. You can let the kids kind of feel this and do this while you are having some discussion. Hopefully they won't, try to press it so hard that the top comes flying off. So you do want to make sure that it's screwed on really tight. I think hopefully they will be when I give them to you. So very, very simple object lesson. You have lots of room to really expand on this. We are going to also give the kids little baggies that have Play-Doh in them, which is something they can take home with them that gives them the same effect. This one, they can actually see through it to where the toothpaste they can. This is an idea that I saw from another director. So they're each going to have a little clear plastic baggie with some colored Play-Doh in it. This just has white because that's what I had. But they can squeeze here, and then we're actually able to see how the Play-Doh is displaced, and it spreads around depending on where we're squeezing at. And this gives us our example of what happens with that magma. I am going to refer the parents to another really great science experiment that I saw. Don't think we'll be able to do it on campus, although if I find a way to, I might, but it's like elephant toothpaste. And it's a reaction where you use like a big 2-liter bottle and it just foam comes out everywhere. It's really, really cool, but I don't know if we'll have time to do that on a community day. However, it would be a really great follow-up for us to send to the parents at home for them to be able to expand on this one if they want to. So most likely I will just send that as a link to our families and let them take that on if they want to on their own. They will get this as a little take-home though, so that's a little added bonus. Okay, so that's everything for science for week 16. Thanks.